space lanes of laser beams emitting conscious signals throughout the galaxy, and unfortunately, we as humans are not smart enough to understand it. Andromeda, our galactic neighbor, we can observe it in our skies without a telescope, which is interesting. However, things have gone from interesting to disturbing and alarming. Michio Kaku has revealed that the James Webb Space Telescope has picked up disturbing signals coming from Andromeda, and these signals turn out to be much more dangerous than we could have ever anticipated. Join us on this journey to discover the truth behind these alarming signals and how the future could be far more terrifying than we ever imagined. Andromeda is a cosmic giant with fascinating characteristics that distinguish it in the vast universe. Also known as M31 or Messier 31, it is the largest galaxy in our region with an impressive diameter of approximately 220,000 light-years, a true celestial wonder in terms of its cosmic magnitude. Although the Andromeda Galaxy lies at a considerable distance from Earth, approximately 2.5 million light-years away, its position in the cosmos places it beyond the limit of our galactic neighborhood. Although its size may be frightening, it is also fascinating to observe its structure. Andromeda shares a similar structural design to our own Milky Way galaxy, with a bar spiral configuration. This feature is highlighted by a central bulge of matter surrounding a flat disk containing stars, gas, and cosmic dust. Its symmetrical structure shows the impressive complexity of this galaxy. In terms of its stellar population, Andromeda is home to an extraordinarily 1 trillion stars, far exceeding the number of stars in our own Milky Way galaxy, which has about 250 billion stars. This explains why it is so visible from Earth, since its brightness is certainly greater. However, the grandeur and luminosity of a galaxy are not the only intriguing characteristics it possesses. Open space hides many secrets, and each galaxy has different and surprising peculiarities. At the core of the Andromeda Galaxy, a concentrated bulge of matter stands out in the spiral structure of the galaxy, illuminating a distinctive appearance. The central bulge is believed to contain a high concentration of stars influenced by the gravitational pull of the galaxy itself. Given that the galaxy has an abundance of stars, it is not surprising that a percentage of them clustered together to form this bulge. In addition, there are more than 400 globular clusters scattered throughout the galaxy, which are spherical collections of stars bound together by gravity. So despite being an immense galactic beast, the Andromeda Galaxy is not alone in space. In fact, it has an entourage of at least 14 known satellite galaxies orbiting around it, forming a fascinating cosmic family. The interactions between the main galaxy and its satellites play an important role in the formation of their respective structures and evolution, contributing to the rich diversity of cosmic phenomena in the Andromeda system. The presence of a ring of dwarf galaxies surrounding Andromeda has been discovered. These dwarf galaxies are relatively small and faint compared to Andromeda and the Milky Way. The finding of this ring suggests the gravitational interaction between Andromeda and these dwarf galaxies, indicating the dwarf galaxies are under the gravitational influence of Andromeda, probably due to the immense gravitational force of this galaxy. The ring of dwarf galaxies is a subject of ongoing research, as the exact nature of this interaction and the mechanisms that led to the formation of this ring are still under study and analysis by scientists. To advance our understanding of galaxies, dark energy, and star formation, including the Andromeda Galaxy, two powerful instruments are being used: the James Webb Space Telescope and the Dark Energy Spectroscopic Instrument. These instruments play a crucial role in the study and analysis of cosmic phenomena, allowing the mystery surrounding the Andromeda Galaxy and its stellar environment to be investigated with greater detail and precision. The James Webb Space Telescope is considered the most powerful telescope ever built, and it is designed primarily to observe the universe in the infrared spectrum of the electromagnetic spectrum. This feature allows it to study the first galaxies forming in the early universe by detecting the faint light emitted by these distant galaxies. The James Webb Space Telescope's goal is to provide valuable insights into the formation and evolution of galaxies, including the Andromeda Galaxy, and its observations will contribute to our understanding of the processes that have shaped the universe over time. On the other hand, the Dark Energy Spectroscopic Instrument, or DESI in short, is an instrument specifically designed to study dark energy and galaxies. It uses optical spectroscopy, which consists of breaking down galaxy light into its different wavelengths to analyze spectra of millions of galaxies. Through this massive spectroscopic study, astronomers can measure the distances to galaxies and obtain information about their properties, such as their chemical composition, formation history, and motion. This analysis of the distribution and motion of galaxies sheds light on the enigmatic nature of dark energy, a mysterious force that drives the accelerating expansion of the universe. In the specific context of the Andromeda Galaxy, DESI observations have provided fascinating insights into the migratory history of stars within it. By analyzing the spectra of individual stars, DESI can reveal information about their chemical composition and origins. This allows astronomers to trace the history of star formation and follow the movement of stars within Andromeda. By learning more about stellar immigration patterns, scientists gained a better understanding of the formation and evolution of the galaxy, as well as its interactions with neighboring galaxies. In addition, recent studies have provided compelling evidence for the existence of a stellar halo in the Andromeda Galaxy that bears similarities to that of our own Milky Way galaxy. This discovery has illuminated the dynamic nature of galaxies and the intricate interactions between them. Observations and simulations suggest that a significant number of stars found in the outer regions of Andromeda's stellar halo have migrated from small satellite galaxies that were gravitationally captured by Andromeda over time. Several dwarf galaxies merged with the Andromeda Galaxy, taking their stellar populations with them. This process of galactic cannibalism is known as galactic accretion or merger. Galactic mergers are believed to be common in the universe and shape the structures and characteristics of galaxies, including Andromeda. The presence of stars from other galaxies, resulting from interactions and mergers with smaller companion galaxies, helps researchers understand the kinematics and distribution of stars in the stellar halos of galaxies such as Andromeda and the Milky Way. By studying the populations of stars in these stellar halos, astronomers can trace the history of galactic mergers and interactions that have shaped these galaxies over billions of years. The stellar halo contains stars that have been absorbed by smaller satellite galaxies or star clusters, and their properties can provide valuable information about the history of galaxy mergers and assembly. This galaxy merger process has been a key factor in the evolution and formation of galaxies, such as Andromeda, and has contributed to the diversity of features and structures observed in them. Through detailed observations and computer simulations, scientists can analyze the chemical composition, age, and motion of the stars that form the stellar halos. These data allow them to reconstruct the time sequence of galactic mergers, identifying the progenitor galaxies that contributed to stellar populations and understanding the physical processes involved in such mergers. Now, this approach is of utmost importance because if this massive galaxy were ever to come into contact with our own, it would be crucial to be prepared with all available knowledge.